Hello everybody, welcome to the World of Control channel. I'm Muhammad, and in this video I want to add a particle swarm optimization algorithm to the full state feedback controller that we made in the previous video for the 2 degree of freedom robotic arm. Make sure that you subscribe the channel and like this video. First of all, I have a function here and a PSO algorithm M file that I need to change. I have this function. I need to change this to my Simulink file name. And here we have 8 variables. Actually, we are going to optimize these eight values here that the full state feedback gains here. So now we need a cost function, so I use a MATLAB function to generate our cost function. The input here is error and the output is cost. Cost is P times E squared, mean square error, and we use, for example, now we can change this P value to, for now, 1. This is our cost function. And then we need to use integrator to integrate all of the instant errors and its workspace block. That is our cost, and we need array, a 2-dimension array. For now, I use 0.001 for the lower bound of our gains, and for example 50 for the upper bound, and the simulation can run for 30 seconds. We use 3 particles and 50 iterations, and I do not change other values of our optimization algorithm. Let's run the algorithm to see if it works. It says that we have a problem. We need a dot here. Now we can see the algorithm is using these 8 values to minimize the error. Okay, we can see that the cost is decreasing. $0.007 is the minimum cost that we obtained. Okay, the iteration 18, 19. Now we can see that it is actually converged to 0.007. Okay, let's stop the Simulink. These are our values. We can use them. This is our full state feedback gains. Let's see. Let's see the reaction and the performance of our controller. I do not see Um, okay, we do not have a nice performance for now. Let's increase this value, and then let this to be upper bound to be 10. Actually, we need to try. We have some warnings here that we do not pay attention to. 3.9 for cost until now. Okay, it's stock. It has been stuck to a value. Let's use these values that our algorithm found. Oh, we see a lot of oscillating. So let's increase the upper bound of our gains to see if the optimization algorithm finds a better solution. 2.5 for the cost. Okay, in the iteration 11, it used a bad combination. Let's decrease time of simulation. Again, .9, 0.1. It is trying other combinations for our full state feedback gains. 0.02, 0.008. It is 0.006. Now we have a nice combination. I set the number of iteration on 50, so the algorithm will operate until the last iteration. We can see that in each iteration it decreases the cost function, and the final cost is 0.0002. So let's use this gains to see the controller performance. Oh, now we can see that our controller is doing a great job. Let's increase the time of simulation. We can see that we have a nice control. Let's change this value to, for example, pi 9th to see the reaction. Now we can see that we have a nice combination of values for these 8 gains. So let's optimize for another input, for example, a sine wave. We need a sine wave, this one to be pi third, is frequency of, for example, 0.5 hertz, and for the theta to p fourth, 0.4. Let's see the reaction of our controller. We can see that we have a very small error between the desired theta 1 and the actual one. Let's see the theta 2. We can see that we have some difference. So let's again optimize for the sine waves of inputs. Sometimes we need to run several times to find a good solution. 0.5, 0.58 is the value of gain, 0.46, 0.43. It shows that it is getting a better solution with changing and trying other combinations of the gains. 0.33. I will stop the optimization in the 20th iteration because I think it converged to 0.29 and it found these values for our 8 gains. 0.19, okay, I will wait a little bit more. 0.18, okay, that's enough. I will stop the simulation and use these values for my controller. This is the optimal gains. These are the optimal gains. Let's run the simulation. Now we can see that we have tracking the theta 1 desired and theta 2, but still I think we do not get a good result. We can change the number of particles here to have a better solution, or the max iterations. And also we can change all of these parameters for the PSO algorithm. And again, run the optimization to find a better solution. Make sure that you subscribe this channel if you want to see more videos about dynamics and designing controllers and optimization. You can subscribe this channel because I'm going to upload a lot of videos about this topic. Thank you very much. Have a nice day.